Hello everyone, my name is Ms. Divyani Harpal, Assistant Professor of Civil Engineering Department, Tulsiramji Gaikwad Patil, College of Engineering and Technology, and Autonomous Institute, Nagpur. Today, we will discuss about some theoretical portion of design of steel structure. This presentation or lecture consists structural fasteners, behavior of bolted and welded connections, failure of bolted and welded joints, strength of bolt and strength of weld, efficiency of joints. Structural fasteners. The structural fasteners are components used to join structural elements in a steel structure. The structural fasteners have many types: bolt, weld, and rivets. Bolts have high strength friction grip bolts. Welded have two types: arc welding and gas welding. Rivets are less common used by the designer due to its many disadvantages. Behavior of bolted and welded connection. Bolted connection transfer load occur through bearing, shearing, or tension of bolt. It has two types: bearing type and slip critical connection. In the bearing type connection, bolt carries load by bearing against connected plates. In the slip critical conditions connections, load transferred by friction between plate and no slip allowed. In the welded connection, continuous or intermittent welds transfer force directly through the weld metal. It has two types: fillet weld and butt weld. Due to this diagram, you can easily see that it is a bolted connection. This is called bolt and bottom portion called nut. Below the nut, the hash marked is called as threads, and above the nuts have plain structure is called shank. In other side, you can see that butt weld and fillet weld. Butt weld is weld metal, and in the fillet weld you can see the weld metal in the angular portion. Failure of bolted and welded joints. Bolted connection failure. It may fail by the bolt shear failure, plate bearing failure, bolt tension rupture, block shear failure of connected plates. You can see here the bolts can fail due to this four type of reason. If we are doing bolted connection in the plates, it may failure due to net tension, and the failure style can see in the A type figure. Same as due to shear out, you can see the failure structure. In the bearing, you can see diagram number C. And for cleavage failure, diagram D can easily view. Welded connection failure. In the welded connection, it will fail weld metal failure, base metal failure near weld cracking due to poor quality, and fatigue failure under cyclic load. The weld defects may be see here. The strength of bolt and weld. The bolt strength may be calculated by the tensile strength, shear strength, and bearing strength. In the tensile strength, it is depend on bolt material and diameter. In the shear strength, the typically 60% of tensile strength will be carried by the shear strength. Bearing strength of the connected plate also considered. Weld strength depends on weld size. It's called as leg length, type of weld, and material strength. The allowable stress is equal to zero point 0.6 into base metal yield strength as per the IS code. The efficiency of a joint in a steel structure design, also known as joint efficiency, is a measure of how much of the solid plate's strength is utilized by the joint. It's calculated by comparing the strength of the joint determined by the lowest strength of its component, such as bolts or welds, to the strength of the solid plate per unit length, typically expressed as a percentage. A higher joint efficiency indicate a more efficient and effective design, as it means the joints can carry a greater proportions of the original materials load carrying capacity. Thank you so much for your attention. Next video will carry other theoretical and basic concepts related to the design of steel structure. Thank you so much.